In this sublesson, 5.4, we'll learn to use PS and top to look at, inspect, and monitor processes. These are very commonly used administrator commands, one of the first tools in your tool belt that you can pull out when you need to log in and start using a Linux system. So I'm logged into my CentOS box with the Vagrant user. First things first, I'll run the PS command. You can see that there are 3 processes running. By default, PS just shows the processes running under my current user account. So there's a bash process, there's a PS process. So I can use, let's just add a little CPU time. You can see there's basically no time being used so far. Bash shell doesn't take up too much CPU time on its own. So let's add a little time so we can just kind of see that increment. So I'll just use a loop for that. So the yes command, its only purpose in life is to echo yes to the terminal. You might wonder why that's useful. It is occasionally useful, in fact, as it has a nice exit code, usable for scripts. In any case, I'm just letting it run here for a second to accumulate some CPU time, and I'll use Control-C to send it kill signal to stop the process. And now I'll just type PS again. And we can see that the bash process at this point has accumulated a little CPU time, 16 seconds. So that means that the bash process was actively being executed by the processor for 16 seconds. Just kind of a little side trip there for you. Now let's check out another example. I'll open up the Gettysburg Address again with Vim, and I'll use Control-Z to get back to my shell and put it in the background. We'll just type PS and look at the table again. You can see that we have Vim running, and PS shows us that it has process ID 2148. So I'll go ahead and close out of it now. Let's look at something a little more interesting. The flags I like to use, and there are a number of variants of what flags you can use. I'm using the BSD style syntax. PS is steeped in Unix history. So in this case, I'm using BSD. Some people like to use an alternative -EF. Flags, which accomplishes basically the same thing. I'm going to go ahead with AUXW, and I'm going to pipe the output of this to less so that we get it one page at a time. And let's just kind of take a look at the command here. So we have a number of fields. We show all the users that are running the processes. We show their process ID, the PID that we just learned about. We show what percentage of the CPU and memory that the process is using. So that's really important. Sometimes when you need to debug or diagnose a problem, you might see that a given process is using a lot of CPU or memory. And that could be expected or unexpected. It just tells you information. It shows you the virtual size and the resident size of memory that the process is using. It shows you what terminal it's running on, and just some additional information. Interestingly, of course, it shows you the command that's running. So this very first command in the process table is init, which has process ID 1. It's taking up some space in memory. It shows you what time it started. All of these processes that show a square bracket on either side are kernel processes. So the kernel is automatically managing them. They are represented here virtually. We can pretty much safely ignore them. I'm going to go ahead and filter them out for now, in fact. And we can do that with our handy grep. And so now we've filtered out all of the kernel processes, and all we see are the actual running processes on the system. Back towards the bottom of the list, we can see a few differences. Most of the commands are running as root, but we can see also the commands that are running as the user Vagrant. We can see the SSH process. We can see that SSH cloned itself and started a bash shell when I first logged into the system. We can show that there's another bash process running. We can even see our running PS and our less command in the output here. Right? That when we run PS, AUXW, and we pipe it to less, we actually, those should show up in the process table because they're actively running processes. So that's why we see them here. Next up, let's check out the top command. So first, I can just run top. And let's run through some of what we're seeing in this list of information. There's a lot of really good details about what the system is doing in top. Up here in the left, it shows me how long the system has been up, 3 hours. It shows me that there's one user logged in. It shows me the load average, and this is showing me 1, 5, and 15-minute intervals, I believe. So the load is the number of processes waiting to run on the system's run queue. And so this is a subtly challenging number to interpret. A system that's really bored and not very busy doing things will have a very low load. For instance, this system is just a virtual machine running on my laptop. It's not really doing much. It has a very low load of 0. On a busy system, say a system that is running a database or handling a lot of web connections or some busy server doing things, this load number will be really high. Really, a safe load number is anything that is below the number of CPUs on the system. So for instance, if you have a 4-core system, 4 CPUs on your server, a load average of 4 or below means that the CPU has some idle capacity. It means it has some room to grow. If it has a load of higher than 4, it's overwhelmed. Every processor on the system is busy, is fully pegged, and there are some processes waiting to run that can't run because the CPUs are busy servicing something else. So you want to keep a really close eye. This is a good one to measure and monitor. We see the total number of tasks or running processes, basically, 86 of them total, 1 running, 85 sleeping, meaning either they don't have anything to do or they're waiting on the disk or network or something else. We see CPUs here. If I type the number 1 on my keyboard, notice that it changes from CPU 0, CPU S, CPU 0. What that's indicating is if I had more than one CPU on this virtual machine, I would show both of them. I would show CPU 0, and right below this would be CPU 1. If I hit 1 again and it shows me CPU S, that's a cumulative number. That's how busy the system is across all of the CPUs. Then we divide this next section into kind of several percentages. We have user, so this is user processes taking up CPU time. And then we have system percentages. So this would be the kernel taking up CPU time. And you'll often see a busy system marking some of its time in user space and some of its time in system space. This is very normal. We see this is not very important one necessarily. This is percentage nice. This is processes that are niced or are deprioritized or prioritized by the kernel in some way. We see idle. This is taking up most of the CPU on my system right now because it's just not doing very much. So most of the CPU is idle. If you see idle on your system, it means one of a few things. It might mean that the system is in fact not doing very much, or it might mean that you have one processor currently being fully utilized and another processor not being utilized at all because the system's not multi-threading very well. So this can be an interesting percentage to look at. This is also an important one. The WA here stands for wait. So this is CPU wait time. It means that some processes are waiting for I/O. They're waiting for the disk or they're waiting for network traffic. In some case, there's a process that wants to run, but it's got to wait for something that's really slower. And if this number is really high, it often indicates that you're bottlenecked on disk somehow. So those are the most important fields out of this list. Finally, there's the memory. So this is telling you what's going on with the memory on your system. It's telling you how much you have total, how much you have used, and how much you have free. And then swap space is virtual memory available to the system. It's generally a kind of a rule of thumb is it's double the amount of memory that your system has. In some cases, it might be 0. And then below that, we have an always changing list of commands. So these are the same commands we see in the process table when we run PS, but this is showing us a little more detail about what process, it's sorted by default by what process is using the most CPU. And you can change which column it's sorted by if you look at the top help. Look at the man pages for top or type the H key to see some quick help.